Hi, this is Mr. Green again. This is another in my Algebra 2 lessons. Not necessary, but thank you. This is another in my Algebra 2 lessons. Where we're at right now, we're finishing up Unit 8. You need to be getting all the work done in Unit 8. We'll be taking the unit exam here in the next day or two. I'll be doing a review during our class connect time frame, but you need to make certain that you get everything completed up. We will be starting to review for the semester final after that. Okay, so what are we doing? We're looking at the last topic in Chapter 8, which is the application of quadratic functions. We're going to solve some semi-real world problems using quadratic equations and functions. There are more complicated ones, but these are going to be ones that you will basically be able to understand. One of the things we're looking at here is if we're looking at a quadratic equation, this vertex might be the highest point that a ball is at after it's thrown. Interesting concept here. So, what do you the teacher is saying, what do you think? A good job teaching quadratic equations? Like me on Facebook. You won't find me on Facebook. So, you can go ahead and like away. So, that's what we're going to be looking at, is solving real world problems. Okay, so here's a real world application. Furniture dimensions. Furniture dimensions. Well, yeah, television screens are described by their diagonal measurements, by their length to width ratio. That means the length divided by the width has a set ratio. Many of the widescreen TVs out there now have a 16:9 ratio. You notice how I wrote it as a fraction. 16:9. That means if we knew the width, it would be width times 16 divided by 9 would be the length. Okay? That's one way of writing that. So, Mr. Scott has a 40-inch television screen. When they say 40-inch television, what they're actually giving you is the diagonal measurement. That means the length squared plus the width squared is equal to 40 squared. So we can write that out as L squared plus W squared equals 1600. Right? But I know what L is equal to right here. So I could actually write that in here. 16 divided by 9, W plus W squared equals 1600. Okay? Well, you know what? That's actually going to be 25 divided by 9. How did I get 25? This is 9 over 9. And 9 over 9 plus 9 plus 16 is 25. 25 divided by 9 times... Oh, wait a second. I left something off there. Scratch that. Back up. Scratch that. Okay. So we got 16 squared over 9 squared. W 16 over 9 W squared plus 9 plus W squared is equal to 1600. So if I work this out and do it again correctly this time, I would have 16 squared divided by 9 squared plus 1 times W squared is equal to 1600. I can work this out as a number, okay? And I'll do that with my calculator here. So, clear, clear, clear. So I'm going to have 16 squared divided by 9 squared equals plus 1 is equal to that number right there. So if I take 1600 divided by that answer, I would get 384. 384.57. So W squared equals 384.57. So W is going to be equal to plus or minus. Well, minus doesn't make any sense, does it? No, because it can't have a negative width. So I'm going to take the square root of 384.57. Going back to my calculator here, I can do that quite simply, and I get 19.6. 19.61, whatever. Well, we know what the width is. Well, we know what the width is now. We can figure out the length by multiplying by 16 and dividing by 9 times 16 divided by 9, because it's a 16 to 9 ratio, and my length is going to be 34.9. Okay? Would this fit in a 37 by 24 cabinet? Well, 37 is less than 34. 19 is less than 24. So yes, it would. And how is this a quadratic equation? Right here. We solved a quadratic equation right here. And I did it by a little bit of factoring, a little bit of distributive process here, and figured it out. Once I found the numbers, I just compared them out. That's one way that quadratic equations are used. Didn't know that a 40-inch TV would fit in a 37 by 24-inch case, did you? That's the way it works. Okay? Another application is called projectile motion. Now, projectile motion could be anything from throwing a ball or dropping a brick. Okay? All of them are projectiles. Anything that is flying through the air is usually a projectile. This formula right here is the formula that works every single time. You notice we got G here. That's the gravitational constant. It's a constant number. Two values are given for it because one of them is in meters, the other is in feet. You just need to make certain you pick the right one. This value, V sub 0, that's the initial velocity. And H sub 0 is the initial height. So if I'm standing on the top of a tall tower and I drop a brick from that tall tower down, I can use this formula. I just need to know my initial height, the height of the tower. My initial velocity is 0, and my gravitational constant that I'm using. And I can figure out how long it takes to reach the ground. Okay? If I were taking a football player and throwing a football in the air, well, I need to know how high the football was when he threw it. Let's give it a certain height. We know the speed. We can figure out the speed in which he throws the football. And then we can figure out how long it would be in the air, what the maximum height is, how long it would take to hit the ground. Okay? Knowing how long it would take to hit the ground, you could actually figure out the distance too, but that's a different story. Okay? We're just figuring out time with this one. This is a function of time. Okay? So that equation works all the time. So here we've got Kyle. He's throwing a baseball straight up from a height of 4 feet, an initial speed of 30 feet per second. So H sub 0 is going to be 4. V sub 0 is going to be 30 feet per second. Since we're talking about feet, our gravitational constant is going to be 32 feet per second. Okay, where did I get that from? This is what was over here, 32 feet per second. And it's going to be a negative number. Okay, so my equation is going to be y is going to be equal to negative 32t squared plus 30t plus 4. Okay, that's the answer to A. Right there, I wrote an equation. They're wanting me to graph this as the height of the function of time. Well, you know what? Calculators are great for doing this. Okay? Let's clear this out. Negative 32x squared plus 30x plus 4. And hit graph. I'm going to have to zoom this a little bit because, you know what, it looks better when I do it this way. Well, not so much. Okay, let's do it this way. So from a minimum of 0 and we're going to go from a maximum height of 4. Oh, wait a second. Someone at my door. Okay. Let's see what we get when we do that. Way too much y value there. Okay. A little bit better. So he throws it straight up in the air and it goes up like that and it comes straight back down. Okay. That's what it looks like. Okay. And you can see what I was doing. I was playing with this function here, this y function. Okay. So let's just make this 5 because I don't think it's going to go much beyond 5 seconds in the air. A little bit bigger there. So he throws it from 4 feet, it goes up that high and comes back down. Cool. So what did it look like? Well, graph like this. It's going to start at 4 feet like this. It's going to go up and back down like that. Okay? So can we find this maximum value here? Why, sure we can find that maximum value. Okay? We've got a couple of points. We know the equation, right? Remember where my axis of symmetry is? Maybe not. Okay? So let's see if we can't just find the maximum value by looking at it here on the graph. Let's do a calculate. Yep, calculate. Push the right button. Maximum value. That'd be number 4. Okay? I need to be at a left bound. Let's see here. Left bound. I got to get on the left side of the maximum here. So there's the left side of the maximum. Now I got to get onto the right side of the maximum. That'd be over there. And then I go back to the point where I think the maximum is and hit enter. And it tells me that the maximum value is at 0.468 seconds and a height of 11 feet. 11.03 feet. So there's B. C would be at 11 feet. Okay? Assuming Kyle doesn't catch the ball, when does the ball hit the ground? Same thing. What are we looking at there? We're looking at when does it hit the ground? We're looking at the 0 value. Okay? That's the left side of it. The 0 value would be when y is equal to 0. So I'm going to get down here till I've got a negative value for y, like that. And then I'm going to come back until I get to close to 0. And I'm going to hit enter. And it's going to tell me that the y value that's almost 0 is at 1.05 seconds. Seconds. See how I used the calculator and I used the graphing approach to solve this one? Works quite easily. Now, Selena bought 12 meters of fencing to make a regular pen for her rabbit. Well, I know the formula for perimeter. That's 2 times the length plus 2 times the width. And that's going to be equal to 12 meters, right? Wait a second. She'll use the wall of her shed as one side of the pen. So mark out one of those lengths. It's only going to have one length and 2 widths. Okay? They're wanting to know what dimension maximizes the pen's area. What's the formula for area? Length times width, right? So if I solve this first one up here for one of my 2 variables, that's a value for length. I can substitute that in here for the length. Negative 2w plus 12 times w. That turns out to be negative 2w squared plus 12w. And that's what she's wanting to maximize. I can substitute that in as an equation. Okay? Y equals, clear, negative 2w squared, oops, squared, okay, plus 12w, and I've graphed this, and I've already got it in a bad zoom. Oh, come on, I must have messed up my equation somehow. Graph. Looks like that. Well, you know what? That's my zoom that's causing that, so I'm going to bring this back down to a standard zoom, and it'll look more like that. Well, my maximum value is what we're trying to maximize. It's way up here, right? It's not going to make me any problem. I'm going to come in here and look for a maximum value for my left side. Well, I'm right here at x equals 0, so that's on the left side. I need to go to the right side, so I'm coming over here to the right side. And there it is, came down to the right side, pressed enter. Now I got to get to somewhere in the middle, and it doesn't matter. I just pick a value there in the middle. And what I come up with is that x equals 2.99, or right at 3, and y will equal, w will equal 3, and the value of the equation will be 18. The area will be 18 square feet, square meters. And 3 meters would be the width. Well, how do I find the length? Well, I can come back up here to this equation, and 3 times negative 2 gives me a negative 6, plus 12 gives me a 6. So my length will be 6. That is how you find those values. That's how you use the ones that you want to be using. Okay? I appreciate you guys letting me know that you're in Algebra 2 every time you send me K-mails. It really helps me a lot. And I appreciate it. And I will see you next class.